Okay guys, so now we're going to talk about the last physical property, that is basicity of your amines. Kebesan, how basic is your amine? Okay, so basicity, it is the opposite of acidity. Okay, kalau acid, that means the ability to donate or release proton. So basicity is the opposite lah. Ability of nitrogen to donate electrons. Kan awak ada amine, kalau macam ni, H, R and H, you have this a lone pair, okay, for your nitrogen to donate electrons or accept a proton. So kalau kat sini dia adalah very negative, okay, dia lebih available to accept proton, okay, dia boleh attack H, okay. Alright, so to increase basicity of your amine, okay, your nitrogen must want to donate electrons or accept proton lah. How are we going to that? To do that, we are going to use electron donating group. Okay, so we are going to look at how what affects the basicity of your aromatic amines. There are two: resonance stabilization and inductive effect. Okay, kalau awak ada attach EDG atau EWG, how do they affect the basicity of amine? Does it increase your basicity atau decrease your basicity of your aromatic amines? So kalau dalam aliphatic, okay, dalam aliphatic pula. First, we are going to look at the basicity of aliphatic amines in gaseous phase. Kalau in gaseous phase, we are going to look at inductive effect. Okay, maksudnya EDG dengan EWG. Okay, in aqueous phase, maksudnya awak ada water. Okay, you are going to dissociate your amine in water. So we are going to see the stability of your alkyl ammonium ion. Okay, so ini macam, ini nak tengok stable tak alkyl ammonium ion awak tu. So maksudnya if it is stable, maksudnya dia sukalah untuk release OH minus. Okay, alright. So first things first, we're going to look at the basicity of aliphatic amines in gas phase first. So in gas phase, okay, so in the gas phase, we are going to look at inductive effect. Let's say if we have an electron donating group, your alkyl group. So what will happen to your basicity? So if you have the alkyl group, what does it do? It will increase the electron density on your nitrogen atom, making it more available to accept H+. So that means when you have alkyl group, your nitrogen will become a better electron donor. Okay, so the basicity of amines will increase with increasing methyl substitution atau more electron donating group. So right here we can see, okay, for basicity of ammonia, primary amine, secondary amine and tertiary amine, okay, methyl ni, bukan methyl ni, ammonia is the least basic because it does not have any EDG. Okay, so here your primary amine, it has one R group, so it will donate electron density to your nitrogen. Okay, kalau here if you have two R groups, more electron density is pushed towards nitrogen, making your nitrogen here more a better electron donor. Okay, banyak lagi electron kat sini, so dia boleh donate, boleh attack H. Okay, bila tertiary amine, when you have three alkyl groups, okay, more electron density is pushed towards your nitrogen. Okay, so this makes your nitrogen here an even better electron donor, so more basic. Okay, so maksudnya awak akan tengok electron donating group je lah kalau amine tu in gas phase. So here these are the sentences that you can use to explain the basicity of amines in gaseous phase. Okay, so you're going to have to first, let's say kalau awak ada ni kan, ni saya dah letak dah terus dia punya ranking of basicity, but in soalan tutorial atau PSPM questions, you have to draw first, okay, to see the class of amine. Okay, so once you draw that, then dah tahu class of amine, then you can say lah how many alkyl groups ni ada. So number of alkyl groups attached to nitrogen increases from, so dari mana ke mana, from ni to this to this to this. Okay, siapa yang paling banyak? So the alkyl group is an electron donating group, 1 markah. Hence the alkyl group increases the electron density on the nitrogen atom, making it more available to H+, 1 markah. So the availability to accept H+ increases from blah 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 blah, 1 markah. Okay, so that's how you explain basicity lah for amine in gas phase using inductive effect of electron donating group. Okay, so now we're going to look at the basicity of amine in aqueous solution. So kalau aqueous solution, that means that you are going to dissolve your amine in water. Okay, lepas tu nak tengok kalau dia basic ke tak. Okay, awak punya amine akan release OH minus. So we're going to see whether our conjugate acid, is it? Conjugate acid, this one, our ion, okay, is it stable or not? Okay, alright, so we're going to look at the first one, primary amine. Okay, so for primary amine, you have one alkyl group. Okay, when you dissociate it in water, you will form alkyl ammonium ion. Like this, you have 4 bonds on nitrogen and you have a plus charge here sebab ada 4 bonds. Okay, kira ni awak nitrogen ni dah capture 1 H. Okay, and kita dah form hydroxide ion, our base. So we want to see whether this primary amine is basic. How is the level of basicity of this primary amine? Okay, so since this primary amine has one alkyl group, so this alkyl group will push its electron density, increase the electron density on nitrogen. So that will stabilize your alkyl ammonium ion. Okay, so kalau dia stable, then that means that it is basic lah. Okay, so secondary amine pula, you have 2 alkyl groups. So lebih banyak alkyl group, okay, dekat alkyl ammonium ion awak tu, more electron density is electron density on nitrogen is increased. Okay, that makes it more stable, therefore it is even more basic. So for secondary amine is more basic banding dengan primary amine. So for tertiary amine pula, we expect it to be even more basic lah, because you have 3 alkyl groups. Okay, so you are you are pushing electron density, increasing the electron density of your nitrogen. Okay, stabilizing your alkyl ammonium ion, right? But however, okay, tertiary amine, it forms alkyl ammonium ion. Its alkyl ammonium ion dissolves poorly in water. So why is that so? Because it has 3 alkyl groups ni. So ini dah kira dia ada large hydrophobic area, kan? Okay, so these for tertiary amine tu kira dia less basic lah than primary and secondary amine. Alright, so that's the basicity of aliphatic amines in aqueous solution. Okay, so now we're going to talk about the basicity of aromatic amines. So there are 3 things that affect the aromatic amine punya basicity. First, it is the resonance stabilization. Okay, resonance stabilization, ingat tak? yang awak delocalize electrons within benzene ring. Then you have inductive effect of EDG and inductive effect of EWG macam tadi tu. Okay. So aromatic amine biasanya kita akan cakap pasal aniline lah. When your benzene ring has an NH2 attached to it, itu adalah aniline. So aniline, it is resonance stabilized. So maksudnya dia ada resonance stabilization. Resonance tu ini, these are your resonance form. Dia boleh, okay, dekat nitrogen ni ada lone pair. So this lone pair at nitrogen can be delocalized within the benzene ring. So dia boleh masuk dalam benzene ring. So sekarang ni awak punya negative charge daripada nitrogen akan delocalize within benzene ring. So sekarang awak punya electron density, what happens? Electron density of nitrogen ni makin berkurang ke makin tambah bila awak tolak elektron tu masuk dalam benzene ring? So electron density on nitrogen is actually decrease lah. Kira awak kan delocalize the negative charge kan? So that means that the electron density at nitrogen is decreased when in aromatic amines. Okay. So tengok ni, ini kan positive charge kan? So maksudnya dia less basic lah. Okay. It makes your nitrogen a less effective electron donor. So aniline is a weaker base compared to ammonia. Okay, so we can conclude that aromatic amines are weaker bases compared to aliphatic and cyclic amines because electron density is on nitrogen is decreased. Okay, when in aromatic amine, awak delocalize negative charge tu, the electron density tu kena share dekat dalam ni. So it makes this nitrogen, okay, have lower electron density, okay, less effective of an electron donor. Okay, now we're going to look at inductive effect, okay, of EWG if you have electron withdrawing group on your aniline or aromatic amines. So what happens when you attach an electron withdrawing group on your aniline? It will make your amine less basic. Okay, why is that? Electron withdrawing group, that means that you are going to pull electron towards the electron withdrawing group. Okay, pull electron daripada awak punya nitrogen ni, kan? Awak ada electron kan, electron density. So when you have an electron withdrawing group, it will pull the electron density towards itself. That means that this nitrogen, okay, that will reduce the electron density on your nitrogen. So this lone pair is hardly being donated. Susah lah nak donate lone pair tu. Okay. So we can conclude that, okay, comparing when you have electron withdrawing group and without electron withdrawing group, okay, your basicity is decreased, okay, when you have electron withdrawing group. Okay, sebab dia tarik elektron density awak daripada nitrogen ni. Okay, your nitrogen has to want to donate electron. So ini dia tarik, dia suck the life out of the nitrogen. Okay. Okay, now we're going to look at electron donating group. Okay, kalau tadi electron withdrawing group akan make your amine less basic. So if you donate electron when you have EDG, it will make your amine more basic. Okay. Let's say if you have alkyl group like CH3 or any other EDG, okay, your electron density, your alkyl group will increase the electron density on nitrogen, okay. So this will make your nitrogen a better electron donor, okay. It will want to donate electrons. So that will increase the basicity of your amine, okay. So here kita boleh nampak yang basicity of aniline with an electron donating group, it is more basic than the normal aniline without any electron donating group. Okay. So 3-methyl aniline ni is a stronger base lah compared to aniline. Alright, so that's basicity.